The Durham Magneto Optics ML3 MicroWriter direct write machine allows the user to do maskless photolithography. The actual exposure is done by a 385 nanometer LED UV light source reflecting off of a DLP chip, which is a digital light processor, with an array of 1 million moving cantilever reflectors. That image is projected down through microscope optics onto the substrate. The light intensity is controlled by turning each pixel on and off for a certain duty cycle during that particular exposure time. The machine stitches multiple images together to create larger exposure areas. It can be set to continually focus to be able to compensate for bowed, lumpy, or tilted samples. Besides watching this video, anyone planning to use the ML3 should also go to this webpage. This page, which is accessible from the Flexible Cleanroom webpage, has a written overview of the ML3. Also, from down near the bottom of that webpage, in the Other Resources section, you should download and read the following: the ML3 usage considerations and the ML3 dose recommendations. And anyone considering doing alignments for multi-level processes or grayscale should read ML3 alignment marks or ML3 grayscale lithography. Again, these are all located on the MicroWriter direct write machine webpage. In this video, I will be going over basic loading, focusing, centering, job list building, and doing simple exposures on several types of common substrates. In a subsequent video, I will be going over doing precision alignments to previously patterned substrates, and I will go into more detail on some of the more advanced features. A few basic things you should understand before using the machine. When you design a pattern on, say, Kluin or any other mask design program you like, the blue pattern that you design will be written as UV light. So it's important to know which type of resist you're going to be using and to make sure that you have the pattern in the correct polarity for what you want to do. When you expose positive resist to UV light, the parts that you expose develop away after development. When you expose negative resist, the parts that you expose are hardened and they stay there after developing. The ML3 writes in the .sif format. We have a license to use Kluin, which is a nice mask design program. You can also use most other mask design programs if you like, but you'll want to convert your final design into a SIF format before trying to write with it on the ML3. An easy way to convert other formats of files into .sif right at the machine is to open it in Kluin, then do a save as, and save a new copy of it in the SIF format. When you design a pattern, it should always be designed so that it's centered on the 0, 0 coordinates, like in the first diagram. If you do it the second way, you're going to have to figure out the offset for X and Y each time you write that pattern, if you need it centered. Okay, let's get started. Before using the ML3, you'll need to go onto Badger and enable the machine. During COVID, you'll also need to enable Room ML3 Quintel so that you will be the only person working in that zone of the yellow room. Once you enable the ML3, the tower light mounted on the wall behind the ML3 will light up green. This green light will let others, even those outside in the hallway, know that the ML3 is currently being used. We normally leave the software for the ML3 running on the computer after using it. If someone has mistakenly turned it off, you will need to click the DMO icon, which is on the desktop, to open the software. This software takes a while to load and it will have to go through a series of stage homing operations. So please don't turn off the DMO software. The only time it might need to be turned off is to reset it if the computer's memory gets overloaded or if the program freezes up. Normally it should always be on when you start to use it. So once you're sure the DMO software is running, check the ring light on the round push button switch next to the door of the chamber to make sure that it is turned off. If it is lit, there could still be somebody's sample inside. It should normally be off. When that ring light is off, the chamber door is unlocked and you can go ahead and open up the chamber. Open the chamber door and gently rest it against the top of the machine. The interior of the machine is temperature controlled to stay within plus or minus 0.1 degrees C, which is very important to maintain proper calibration of the laser interferometry system and the optics. So please don't leave the chamber door open any longer than necessary. The ground glass wafer chuck moves forward for easy access during loading, but once you close the chamber door, the stage moves under the black box at the left rear, which contains the optical system. There is no vacuum on the chuck. Friction along with slow acceleration rates for the stage keeps your sample stable during writing. While loading your sample, it is very important not to touch the long, skinny laser interferometry mirror to the right of the stage. Also, don't rest your hand on the stage. It's fine though to rest your wrist on the ledge of the door frame to give your hand some stability while loading the sample. Keep a firm grip on your samples so that you won't accidentally drop it down inside the guts of the machine. The chuck has sort of a bullseye pattern of lines and circles to help manually center most standard size substrates. This stage will accommodate up to a 200 millimeter by 200 millimeter, which is 8 inches by 8 inches square substrate. You should know the rough dimensions of your sample prior to putting it into the machine. For this first demonstration, I'll be using a 4-inch wafer, or 100 millimeter wafer. Notice that the flat is facing towards you. There's a pattern in the chuck to help you remember that. It doesn't need to be perfectly centered. Just center it by eye so that it looks roughly aligned with the corresponding etched ring pattern in the chuck. It's okay to scoot it around a little if that helps. Once the wafer looks fairly well centered by eye with the flat facing towards you, close the chamber door. Then press the round button to the right of the chamber door. The light will start blinking red. The light will keep blinking until the XY stage moves the sample underneath the optics in the rear of the machine. When the red light stops blinking, you are ready to start focusing. Depending on what the last user was doing, you might see something like this on the screen, or you might see something like this on the screen. Either way, you want to go to this box over here and click Align Wafer. There are 3 basic steps that you're always going to be doing. The align wafer step is where you focus on the wafer and align and center it. The second step is where you prepare the pattern that you're going to be writing. And then the final step would be the exposure step. So in the beginning, you're always going to start out with the align wafer step. The ML3 has 4 lenses which are associated with 4 different writing resolutions. The 3x lens is for writing at a resolution of 5 microns. The 5x lens is for writing at 2 micron resolution. The 10x lens is for writing at a resolution of 1 micron. And the 20x lens is for writing at a resolution of 0.6 microns. The lower powered lenses have a long working distance, while the higher powered lenses have a short working distance. You should really know what you're doing before moving to higher powered lenses to make sure you don't crash the lens into the substrate. Initial focusing should always be done with a low powered lens. Whenever you load a substrate into the machine automatically goes to the 5x lens. So once you click on the align wafer step, you should see a screen that looks something like this. It will automatically go to the ×5 lens, and you'll see probably a blurry image of the wafer. It will go to whatever Z height, shown as the thickness in microns here, of what the last user was working with. Since you have no idea what the thickness of the previous user's wafer was, you will need to set it to the correct height so that your substrate will be in focus. There is an autofocus feature, which you could click now, but the machine may take a long time figuring out how thick your wafer is, because it has to wander up and down a little while. If you knew the thickness of your wafer, you could just type that in here and hit the return, and the Z stage would jump to that height to give you a head start. But usually the quickest way to focus is to go to the microscope pull-down menu and click on Focus Assist. Focus Assist projects a very coarse checkerboard pattern onto the substrate. You can then use the thumb wheel on the mouse as a way to manually focus. Keep going up and down on the thumb wheel until the checkerboard looks in focus. Once you have it in a pretty nice focus, go back to the microscope pull-down menu and then click on Focus Assist again to turn the Focus Assist off. Now you can go ahead and use the automatic focus to make sure that works fine. For automatic focusing, it uses an even finer checkerboard pattern to get a more accurate focus. If it has a hard time focusing, you'll see this green bar only go part way to the right. If it goes all the way to the right, that means it had no problem and the machine is satisfied that it's 100% focused. To start the wafer centering process, you would go up to the wafers pull-down menu up in the upper right corner, pull that down and click Current Wafer Properties. And you'll get this window here that opens up. This is a round wafer, so you click the round wafer at the top here and enter the diameter in millimeters. This is a 100 millimeter wafer. The box that says Edge Exclusion, right now it's entered 5 millimeters. What this is it'll give you a sort of a guideline in later steps as you're deciding on where to place the patterns on your wafer. This would be like if you wanted to keep any patterns from getting within 5 millimeters of the edge. So it won't actually keep you from writing in those areas. It will just give you a guideline to let you know whether the way you set up your patterns is all within that guideline. So in this instance, you'd have basically a 90 millimeter area to set up your patterns in. So now that you've entered those two boxes, click on this icon, which will put the wafer through the automatic centering process. You'll see some crazy patterns on the screen like this as the laser finds the edge of the wafer. On a round wafer, it will look for 3 edges, and it will stay away from the flat area of the wafer. That's the reason why the flat needs to be facing towards you when you put the wafer into the machine. During the centering process, you'll see this green progress bar showing your progress. When the green bar gets all the way over to the right, it will be centered, and then all you have to do is hit OK. Once you hit OK, you're acknowledging that the wafer is centered now, and then now 0, 0 on the coordinates will equal the center of the wafer. It is no longer the center of the stage, but now it's the center of the wafer, since you've done the centering step. If you happen to be moving around the wafer and you want to just go back to the center of the wafer, you can always click this little homing icon here, which will send the stage right back to 0, 0. It's always a good idea to focus using the lens that you'll be using to write with before you go further with the process. I didn't show this step, but you would go to the magnification box here and click it to ×3 if you were going to be writing with the ×3 lens. That would be for 5 micron resolution. And then once you get to the ×3 lens, you would want to focus it again. So we're done with this first step. We have the wafer centered and it's in focus using the lens that we're going to be using to write with. Now you want to click on the Prepare Pattern box right here. This is where you set up the jobs that you want to write. A job can be, you can have one job for the entire wafer, or you could have a bunch of jobs spread out all over the wafer, or you can use a job builder where you could take a pattern and fill the wafer with that pattern. This is still set up for the previous user, whatever the previous user was doing. So what you want to do is click the job number, or if there's a bunch of jobs, select them all, and so they're highlighted, and then you'll be clicking the X to erase them all so you can start fresh. Go ahead and click Confirm Deletion of one job. Okay, now you have a clean slate. Go ahead and click this plus sign to add a new job. Right now it's a blank job. You have to select which pattern you want. Click this little icon here with the dot dot dot, and then a window will open up where you pick the pattern that you want to write with. I happen to have this in a folder on the computer already. However, your pattern might be on a memory stick that's been plugged into the machine. This is a really simple pattern that's just a bunch of 2.5 millimeter squares in clusters of 16. So this one job will make 16 of these small squares. When you have a particular job selected, the big red box signifies the overall shape of the pattern that's shown to the right. It doesn't show actual details of the pattern, it just shows the outer dimensions of it. You can see by the display size above, the 25 millimeter represents the white square that the red square is inside. Obviously I can put way more than one of these patterns on a 4-inch wafer, so I'm going to add some more patterns. So I hit the plus 8 more times, and now I highlighted all of those 2 through 8 so that I can enter the same pattern for all 8 of those jobs. So I hit the little dot 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 box again, and then the same folder that I previously opened up will open up. I'm going to select the same pattern. However, I could put a different pattern if I felt like it. I can pull a different pattern from a different folder, it doesn't matter. So now I have 8 of those patterns all on the same 0, 0 coordinate. They're all stacked up on top of each other. There's an automatic way to set up jobs so that they're spread out all over the wafer evenly, but I'm going to show you how to do it manually in case you just want to decide where to put the patterns on the wafer the way you see fit. For whichever jobs you have highlighted, you can change the X and Y positions. You could do them one at a time, or you could do whole groups of them at a time. This display on the right shows the exposure size for the job that you have highlighted. So you can get an idea how much you might want to move the patterns to spread them out to wherever you feel like. When you make a change doing this, it won't show up until you click another job, and then you'll see where the one that you just changed wound up. It will show up as a thin green borderline. Again, this is the slow, tedious way to do this. There are automatic ways to do this, but if you want to be able to decide where you want to position each pattern manually, this is how you go about doing it. Just change the coordinates for each one. You can also change the coordinates for a whole group. Say you want to move 3 patterns to the left, just change the coordinates for X for that group of 3. Whenever you select a certain job or a group of jobs, you can make changes to that. Like you could write three jobs at one resolution, 3 jobs at another resolution, or you could change the dose, or you could change the writing quality. You can change anything you want for any job. They're all treated as separate jobs. They could be written with 4 different lenses or whatever you want. Remember that whichever job you have selected, the one that shows up as red, is the one that you're going to make changes to. If you have all of them selected, you'll be making the change for all of the jobs. The default setting is to write at 1 micron resolution. I don't want to write at 1 micron solution, so I'm going to be changing the resolution for all of the jobs to 5 microns. And for all of the jobs, I'm going to be writing at normal quality. For all of the jobs you're writing, you should usually check this advanced box and open that up, and you'll get a screen like this. You want to double check to make sure that the previous user hasn't checked invert exposure. If that was checked and you didn't know it, you would get a negative of what you want. If that happens, what it will do is put an arbitrary box around your design, and then everything that would normally be at the background would be written in UV, and your pattern would be not written. These 3 settings are usually good for most work. Real-time focus correct fastest, local alignment none, and check enable best stitching on the bottom box. So now for all 9 of these patterns, I have selected normal for the quality, and the dose correction is 1. What dose correction is if you wanted to have a bunch of different doses, you would select each one at a time and put in a different number there. Whatever number you enter there will be multiplied by the global dose, which is in the last step. So say your global dose was 100 and you entered 1.2, the dose for that particular job would be 120. Also for all of these, I've entered them as 5 micron resolution. And then the exposure mode on the bottom is normal. I won't go into all the different exposure modes right now. Normal works for most things. If you remember, during the centering step, there was an exclusion area. So it's basically a 100 millimeter wafer with a 5 millimeter exclusion area. So that resulting 90 millimeter circle is shown as this gray border. It's just to give you a guide while you're deciding where to lay out patterns on your wafer. So now the jobs have been all properly set up. The next step is to go to the expose step. Click the expose box to the right here. So now we're on the expose step. You can see up here in the upper left corner, it says focus lock. It shows a red dot. That means that some previous user has turned off focus lock. So now's a good time for me to go into what focus lock is. Focus lock is a system where the ML3 maps out the slopes or contours of the wafer before doing any actual writing by moving to points just outside your pattern write area and focusing carefully. Focus lock is usually done in conjunction with real-time focus. It allows the ML3 to anticipate movements in Z before it gets to the real-time focus steps as it prepares to write within a certain region of the wafer. You generally want focus lock turned on unless you have a substrate which you know is difficult for the ML3 to focus on. If you will be using a fixed focus with no real-time focus, then you would want to turn off focus lock. During the focus lock step, you will see these focus lock points show up on the screen. While the stage is moving towards the location and prior to being fully focused, the symbol will be yellow. Once the location has been carefully focused, the symbol will turn green. For a small cluster of patterns like this, all drawn at the same resolution, the focus lock points would be in an arrangement like this. If you're doing 3 separate jobs with 3 different resolutions, it's going to be using 3 different lenses, so there's going to be a group of focus lock points for each job. If you have selected high density meshing under the focus lock options, then you'll likely see something like this. Since there's more focus lock points, it will take longer to get through the focus lock operation prior to doing the actual exposure. If you have patterns all over your wafer and you select high density meshing, then there's going to be a whole bunch of focus lock points scattered all over your wafer. Doing this step, though, may add 5 or 10 minutes to the time it takes to expose your full wafer. So now I'm going to go up to the Tools drop-down menu and make some changes to the focus lock settings. You can see now that the previous user left all of the boxes unchecked and left real-time correction as none. This is what you would do if you had a substrate that was very difficult to focus on, or if you had a pattern that ran off the edge of your chip. You might want to use a fixed focus, so you would turn all of these off and real-time correction would be turned off. If the machine doesn't seem to have any problem focusing on your substrate, what I usually like to do is check the first 4 boxes in there. And then I'll pick either laser or DLP for the real-time correction. It uses 2 different methods of focusing for the real-time correction. One is using a red laser dot, and one is using a yellow DLP pattern projected onto the substrate. Sometimes one will work better than the other on certain substrates. I usually select DLP. I think DMO recommends the laser though. So now I checked the first 4 boxes and DLP, but I actually made a mistake here. I should have hit OK at this point to enter those changes. So since I didn't, you'll see on the next screen that focus lock is still lit up as red. I never hit OK. If I had hit OK, that focus lock up in the left corner would look green. That was a mistake. Up in the upper right corner is where you enter the dose that you're going to use. They have it listed as resist sensitivity, but it's actually where you would enter the dose that you want to write at. This is the global dose. So whatever you may have entered in the dose correction factor for the various different jobs that you entered on the prepare pattern step, it would be multiplied by this number. The previous user had entered 160, but I'm going to change it to 120. You see the box below that for global focus correction. I usually leave that at 0. Occasionally you may want to put a number in there if you're working with very thick resist. Normally you're focusing on the surface of the resist, but this would be if you wanted to focus slightly below the surface or slightly above the surface, which you might want to do to change the edge profile of the resist after exposure. People working with very thick SU8 will often put a number in that position. For most photoresist though, you don't need to do that. So now when you're ready to go, you hit this green light here to start the actual exposure. Since I made a mistake and didn't turn on focus lock, it's giving me this warning now that focus lock hasn't been done. I hit OK anyway. This means I'm going to be just writing at a fixed focus height. But then I hit stop and went back and corrected those settings and hit OK this time. Now you can see focus lock is lit up green. So now I'm ready to go with focus lock on and real-time focus on. So I hit the green light to start the exposure, and now we can watch the exposure process take place. Here it is about 5 minutes into it. You can see it's writing one right field at a time and just works its way down through the patterns. There's a countdown timer to the right that's telling you how much time is remaining in the job. These 3 little green target marks are the positions of the focus lock. Since we didn't do the high density focus lock, there's only the 3 for the whole wafer. It's mainly to tell the machine the slope of the wafer if the wafer was cut on a wedge. This little sliding arrow on the right shows what's going on with the real-time focus correction. It's real easy for this to stay in focus because we're just using the 3x lens right now. So basically you can just see it's sitting at 0. If you were doing something with a higher powered lens like 10x or 20x, you would see that moving around as it's following the contours of the surface of the wafer. When it's almost done, you'll see down at the bottom that it says tidying up, and then a minute later it will say finished. That's when you can go ahead and take your sample out of the chamber. Push the little button to the right, it'll start blinking. When the light stops blinking and turns off, you can go ahead and open up the chamber and take your wafer out. Then close the chamber door. You're all done. Next, I'll demonstrate how to pattern a around 20 by 20 millimeter chip, and we'll use the job builder function this time to make setting up the jobs quicker. It'll speed up the centering process if you have a pretty good idea of what the size of the piece is. I just get it roughly centered by eye. Doesn't need to be perfect. Close up the chamber and hit the little round button. When it stops blinking and goes solid red, you're all set. Whenever you load a new sample, it always goes to the 5 times magnification. And I'm not going to go over the focusing again since we already went over that. This is a screenshot of the autofocus taking place after clicking the focus icon. I already pulled down the wafers pull down menu and clicked on Current Wafer Properties to get this window to open up. This is a rectangular substrate, and it was 20 by 20, so that's what I entered in those two boxes. And for this one, I put an edge exclusion area of 0.5 millimeters. Now I'll go ahead and click the wafer centering icon, and it will start the wafer centering process. If you were pretty close on your guess on how large the piece is, this centering process will go quicker. When this green progress bar goes all the way to the right, then it's done. Then you just need to hit OK, and then close up that Current Wafer Properties window. I'm going to do this job at 1 micron resolution, so I'm going to switch over to the ×10 lens. The screen goes dark while the lenses are changing. It might take 30 seconds or so for it to switch to the new lens. Okay, now it's on the ×10 lens, and I'm going to click on the focus icon to get it to do the autofocus again for this lens, since it'll be slightly different from the previous lens. By this green bar being all the way to the right, you can tell that it had no problem with the focusing at the 10x lens. So now I know it's in focus with the lens that I will be using to do the writing. Now I click Prepare Pattern over here to the right. Now I want to clear out all the jobs that are in there right now from the previous use. I select them all, click the red X. The red X deletes all the jobs that are selected. And then you say Confirm Deletion of 9 jobs. Yes. Now we're starting with a blank slate again. This time I'm going to use the Job List Builder. So go up to the Tools section, click on Job List Builder, and then this page opens up. This is what you use if you want to fill the whole wafer or the chip with a bunch of the same patterns. So you click the ... Look through your folder and pick a pattern that you want to use. Now it's loaded in there. This is a rectangular substrate, so I clicked on Rectangle. I want to fill about a 7 millimeter by 7 millimeter area, so I entered 7 and 7 for the size. I'm putting a bunch of 2 millimeter patterns, so I'm going to enter 2.2 and 2.2 for the center to center separation of the patterns. With this job list builder, you could also prepare a dose test gradient along the x-axis if you want. I entered 10% change. That will only be in the x-axis. You could also have a focus test gradient in the y-axis. If you don't click either one of those, then all of them will just have a dose correction factor of 1. So with the numbers I entered, you can see the resulting layout will yield 9 right fields arranged in 3 columns and 3 rows. If you're happy with that arrangement, hit Add to Position List. Then those jobs will be loaded, saving you from having to enter them one at a time and position them one at a time. You can click on the number for the job one at a time, or you can click on the position of it on the screen, or you can click on all of them at once. Then you can make changes to all of them at once, or you can go to make changes to one of them at a time, or a row of them at a time. You've already got them arranged in X and Y, so don't change the position of them all at a time or you'll lose all of that. So I've set the quality for all of these at normal and the resolution at 1 micron, which means I'll be using the 10x lens. The dose correction is from when we set up the dose gradient. So it's going to be a different dose for the 3 columns. I selected normal for the exposure mode for all of them. I'm just checking one here. If I didn't like the way the dose gradient was set up, I can just click on the patterns one at a time and change the dose correction factor for each one at a time. Or I could do a row of them at a time, whatever I feel like. I just picked one pattern here. I'm going to check under the advanced features section just to make sure nothing strange is entered in there. Everything looks good. Invert exposure is not checked. Fastest for the real-time focus correct is checked. None for the local alignment is checked. And enable best stitching is checked. That all sounds good. If you make any changes, remember to hit OK. And if you did make any changes, this is just for one pattern. So if you needed the changes for all of them, make sure you have all of them selected while you're making the changes. So here I selected all of them and I clicked the quality to be high. That's for all of the patterns. For the display size up here for this layout of your patterns, you can put a different number in there if you want, just to see how the layout of your patterns looks in comparison to the size of your wafer. When I click the 25 millimeter display size, remember we had a 20 millimeter chip with a 0.5 micron exclusion area, so that gray border signifies that area which is basically a 19 millimeter square. You can see that the patterns obviously all fit within the center of the wafer fine. Once you're happy with the layout of everything, go up here and click Expose to go to the Expose window. You can see up here that the focus lock is lit up green, but I'm going to go to the Tools and Focus Lock options just to make sure everything's set right. Everything looks good. The first 4 boxes are checked, and for the real-time correction, DLP is checked. So I'll hit OK. And I'll check the doses what I want. Right now it says 120. I think I'll put 100 for this test. Everything's set. Hit the green button to start the exposure. So it says it will take 8 minutes and 3 seconds to do this. These are the focus lock points. Once they're green, it means it's already done with the focus lock operation. Now it's going to start writing. Remember that we are using a 1 micron resolution, which has a really small write field, and we're also using the high quality, which has more of an overlap. So this will take longer for the same surface area as what we could do at a lower resolution. If you look at the individual write fields, you can see that they're overlapping a little bit. That's because the quality is set to high. After it finishes writing, you'll see down here in the bottom tidying up. I'm not sure what's going on right now, but then after a few seconds, it's done. And then it will say finished. Then you can go ahead and take your sample out of the station. Click the button, wait for the little light to stop blinking, and then you can take it out. Remember that it's fine to rest your arms on the ledge at the front of the opening, but don't hit the mirror on the right side. This is for a delicate interferometry system. Now I'm going to demonstrate patterning on an ugly little chip, and I will briefly explain the virtual aligner feature. This little chip's only a couple millimeters wide, and it's an uneven shape, so it'll be good to show you how to deal with odd-shaped little parts like this. Place it close to the center, but make sure it's sitting on a flat surface. You wouldn't want it, if you had a really tiny part, you wouldn't want it to sit in the groove in the plate. Close the lid, hit the button on the right, wait for the light to stop blinking and turn solid red. So without even focusing, I can tell that I'm on the edge of this little chip. You can see the fringe patterns. This is the curved edge. It was off the edge of a wafer. So what I want to do is move over to more into the middle of the chip before I even focus it, because this edge has a slope to it. There are several ways to move the stage around. One way would be to just enter a number in X or Y and it will jump to that position. Another would be to double click anywhere on the screen and the stage will jump to that position. That's a nice way to sort of walk your way over on a small chip like this. And then another way is you click and hold somewhere on the screen and the stage will start to move in that direction. Depending on how far away from the center you are, will control how fast it goes. So if you click close to the center, you'll start moving in that direction slowly. If you click out near the edge of the screen, it will move really fast that direction, so fast it'll be a blur. Since this part is pretty small, I'm going to use the double click method to kind of walk over. I'm going to double click on this little scratch up here on the left, and then now that scratch is right in the middle. Wherever I double click, it's going to walk over to that position. Now if I double click on this black dot over here, it's going to jump over to that position. So I'm basically just looking for a flat area that'll be good to focus with. So I go up to the microscope pull down menu and click on Focus Assist. Then you get this blurry checkerboard pattern. Use the little thumb wheel on the mouse to get it in focus manually. Once that looks good, you go back and turn off the focus assist and then click the automatic focus icon to see how the machine handles this pretty ugly surface of this chip. It actually focused with no problem. You can see the bar is all the way green. If it had focused with the bar only halfway over or just hung up and couldn't focus at all, you can hit the autofocus icon again and it will stop trying to focus. If that were the case, you can just use a fixed focus. So you would manually focus and you would turn focus lock and real-time focus off during the exposure. That way it would just be at a fixed focus height throughout the exposure process. So I went up to the microscope pull-down menu and clicked Wide Field Viewer. This is actually left over from a previous user. I'm going to hit the green button here to start over again. What this will do now is make a mosaic image. It starts in the middle and it starts spiraling around counterclockwise. It's stitching together a bunch of high definition individual images, and it knows the coordinates for any point on any of these images. So I'm just spiraling around this little chip and it's creating a map of the entire chip. So this will always be in the background now. I can use it as a reference to jump to certain points on the chip. Anywhere I double click on this wide field view, the main microscope will jump to that position. So it's a nice way to speed up getting around on a goofy shaped sample like this. You hit the stop when you decide you have enough in view. You can push that aside or put it in the background if it's in the way. So now anywhere I click on this, it will jump to that position. Sort of a roadmap of your chip. It's also a good way to sort of inspect large areas, like you can look for some defect and then look at it up close to see what it looks like. So I'm just sort of looking it over, deciding where I want to try to write a pattern that it's not going to land on some giant defect. I should have turned up the brightness before I took that mosaic image. But say I want to pick an area up here and sort of the top end of it here. I'm going to just pick 3 points, sort of an L shape, that I want to sort of center it in that region. So I went up to the alignment pull down menu and I get this window. What I'm going to be doing is marking 3 corners in the upper area of this chip. So I'll use this like a road map to jump to certain spots on the chip. When I double click it, I'll go to that spot. So I'm going to mark this where the crosshairs are as the upper part of the L that I'm going to use. I'm just going to pick 3 corners in an L shape. Now I'll mark this as marker 1 by clicking the green arrow. Now I'll jump to another location to mark the corner of the L. Then I'll click that to mark it as marker 2. Then I'll click one more time wherever I decide the right edge of the L should be, and I'll mark that as marker 3. I'm doing it in an L shape, but it doesn't have to be in an L shape. You could pick 2 points and it'll be like 2 opposite diagonals, and it'll center between those 2 points. If you pick only 1 point and you center it, it will just be a 1-point alignment. So whatever point you pick, that will be the center of the chip. And if you were working with a tiny square chip, what you might want to do is mark the 4 corners of the chip and then hit the center icon and it will center it by the 4 corners. So this center icon on the left is for when you have 1, 2, 3, or 4 points. The one on the right is for round parts or odd-shaped parts where you're only going to pick either 1 point in the middle or 3 points around the circumference of it. If you click that one, what it'll do is center it based on the center of mass of the part, depending on where your points are. But for what I'm doing here, I'm going to be clicking this square one. If you notice down here on the coordinates, they're all at 0, 0, 0 right now because we're still at the center of the chuck. Once I click this centering process, you'll see that they all change to the new what we decided is the center now. Click. Okay, now it's centered, and we're going to go up and click Prepare Pattern. So there's still a bunch of patterns from a previous job there, so what we want to do is select them all, then hit the red X to clear them out. Then I'll click the plus sign to add a new pattern. Then I'll click the 1 to highlight it. Then I'll click the ... icon to select the pattern that I want to use for job number 1. For this, I'm just going to select this little bullseye pattern. The actual pattern is shown as blue on the right. The red box just signifies the overall dimensions of the pattern that's shown to the right. Right now it's set for the quality of normal. I switched that to high. The default resolution is 1 micron, but I'm going to switch it to a 0.6 microns. I'm opening up the advanced exposure options. Everything looks good in there. You can see the focus lock dot up in the corner is green. But I'm going to open up the focus lock options just to make sure I like what's in there. It seemed to have an okay time doing the autofocus, so I have the first 4 boxes checked, and I have it set to DLP focus. If it had a hard time focusing, I would uncheck all of those boxes and then just have a fixed focus. With a fixed focus, nothing terrible happens if your pattern happens to run off the edge of the chip, because the lens stays at the same height. But whenever you're using the 0.6 micron resolution, or even the 1 micron resolution, you want to make sure that your pattern fits completely onto the substrate if you're going to use real-time focus and focus lock. Remember that at the higher resolutions like that, the lens is very close to the substrate. If it's using real-time focus and it goes off the edge of the substrate, there's a risk of crashing the lens into the substrate as it comes down looking for something to focus on. So you always want to make doubly sure that if you're using autofocus, that your pattern is completely on the substrate. So I'll be using a feature called Virtual Aligner, which will help make sure that the pattern falls completely on the substrate. So to use Virtual Aligner, you have to go up to the Tools pull-down menu and click Exposure Options. And then you have to click the top box where it says Only Prepare Data, Do Not Expose. Then you would hit OK. Then you would hit the Go button as if you were going to do an exposure. Since you hit Only Prepare Data, Do Not Expose, what it's going to do now is render a very high resolution image of the pattern that you're going to be writing. And it aligns to the microscope image very accurately. After you hit the Go sign, you'll get this little pop-up window that says Data Calculation Only Mode. That's what you want to see because you're rendering the Virtual Aligner image. So click Yes. So then watch the green progress bar and you can see how long it's going to take to do the rendering. This actually took a lot less time. I think 1 minute 24 seconds is what it would take for the actual exposure. But to render this tiny little pattern actually only took about 2 seconds. So now that the pattern is rendered, now you have to go back to the exposure options panel and uncheck that box where it says Only Prepare Data. After you uncheck it, hit OK. Then go back to the Align Wafer step so you can see the microscope image. It's on the 3x lens right now because when I did wide field view, I used the lowest power possible so that each frame was covering the largest area as possible. But I don't want to use ×3. I should be focusing on ×20 because I'm writing at 0.6 micron resolution. So I switched it over to ×20, use focus assist, and then I manually focus. Then I let the machine try it out. The machine did a good job, so everything looks good. So now it's in focus with the 20x lens, and I'm going to get ready to show the Virtual Aligner. I go up to the Alignment pull-down menu and click on Virtual Mask Aligner. And then there's an option to the right, Show Pattern to be Exposed. I click on that. So the pattern I'm going to be exposing now shows up as purple overlaid over the microscope image. I can move all around. Right now it's like a virtual mask. It's locked to the wafer, so as I move the wafer around, the mask and the wafer move around together. By the way, when you're in Virtual Aligner mode and you're seeing this purple image, the purple is representative of where the UV light is going to be projected onto your substrate. So now I can check to make sure that this pattern fits all within the surface of the wafer. And if there were some defects, I can unlock the pattern, move it a little, and then lock it again. So I'll show you that in a second. So go up again to the alignment pull-down menu, and then click Virtual Mask Aligner. Right now it says Show Pattern to be Exposed. You want to keep that, but you want to go back and click Release Mask from Wafer if you want to move the mask in relation to the wafer. If you want to move it in very tiny increments, you can just tap these side to side and up and down buttons on the keyboard. It'll move it in, I think, sub-micron movements. I'm tapping it up and down a little bit. You can see that the stage is moving up and down, but the mask is holding still. So if you're happy with the alignment of the virtual mask to the microscope image, go up to the top and uncheck Release Mask from Wafer. Now they're locked together again. Then I'm going to go ahead and turn off Virtual Mask Aligner and go back to the exposure step and hit the green light Go button to start the exposure process. It's a little hard to see here, but here's the first of the yellow focus lock points. When that turns green, then that one's focused. Then I'll move on to the next one. Okay, that one just turned green. There's the next one about to turn green. And then the one on top. Since I have the quality setting at high, you can see there's a large overlap for each separate write field. If you see it slow down occasionally, it's probably because it's having a little more difficult time to focus on some real ugly part of the wafer with a big bubble in the resist or something. When it's about done writing, it'll say tidying up. Then a few seconds later, it will say finished. After it says finished, you can go ahead and open up the chamber. Push the button, wait for it to stop blinking, and take out your sample. Then gently shut the chamber door. In part 2, I will go over precision alignments to existing alignment marks, different writing modes, and some advanced features. Please note that the descriptions in this video apply to the ML3 software version 3.13.1. Future versions of the software may have minor changes. Thanks for watching.